f of t sub 3 dot dot dot, the pattern continues. What's the last one we see in the set? Plus f sub t sub n, f of t sub n, sorry. And what would I divide by? Okay. This means that there's n things there, so I would divide by n. Making sense so far? I want to point something out to you. There's a symbol that we use for adding things up. What symbol is that? Summation notation, and we said in calculus the summation notation is same as the integral. I'm trying to lay the groundwork here. So this is why this is going to tie into an integral. Okay. The larger the number of measurements, the more accurately this will reflect the average temperature. Doesn't that make sense? If I would cut, like if I did it once an hour, it would be 24 hours. But then if, let's say I did it once every half hour, then I would have it 48 of them to do, and so on. Notice we can write the expression as a Riemann sum by first noting that the interval between the measurements will be delta t 24 divided by n. Agreed? If I had 24 hours and divided them by n. So n equals 24 divided by delta t. Let's substitute this expression in for n above. Do you understand that that equals that? Okay, delta t is 24 divided by n, so if I rearranged this expression, I could solve for n. Okay. Let's write it now. F of t sub 1 plus f t sub 2 plus, can I just do this? F of t sub n. And let's see if you can go back to middle school. If I'm dividing by 24 over delta t, okay, when you, that's the same thing as multiplying by its reciprocal, agreed? So I'm going to then at the end write times delta t over 24. This last expression gives us an approximate average temperature as n increases into infinity, meaning that we just said the more temperatures we get, the more intervals we make, that's going to be more accurate. This Riemann sum becomes a definite integral. Write the definite integral that gives us the average temperature since midnight. Okay.
Is that supposed to be over n, or is it just...
What do you mean? No, I took n out.
Oh.
And in its spot I put this, but dividing by n is the same as multiplying by this, so I just put it over there. Here, I'll highlight. I'll color code it.
Well, I'm just confused.
That,
Fraction line.
agreed.
Nothing.
I started to do that, and then I said, okay. So let's write this as an integral. This 24 is pesky. That's not in any of our Riemann sums. But we learned yesterday if we have a constant, what can we do with it? Let's bring it to the front. So this is the same. Let's put that 1 over 24 to the front. And as we said, instead of adding up, we're going to use what symbol? Summation. But in calculus, we're going to convert it to a integral. F of t, that's telling me to add these up. I'm just adding these up. Add up the f of t's, delta t. And this could be 1 to n or 0. I mean, really, we could start it at 0 if we wanted to. We could start at hour 0, right? Let's start it at hour 0. Okay, so do you think that there is any point during the day that the temperature reading on the thermometer is the exact value of the average temperature then?
Sure. Average value theorem.
Wouldn't it have to? It is. It's kind of like the mean value theorem. It's like if it's hitting all those average temperatures, even if it was in between two, think about temperature. You don't just go from 70 to 75. It doesn't just hop up. I mean, it has to go through all those other points to do this. So we're going to say yes. So the average value function, definition, are you ready, Xander? Because this is the important part, is not just the integral, but it's the integral divided by the interval. Say that out loud. Integral divided by the interval. Say it again. Integral divided by the interval. Average value. That's going to be important that you recognize that. So highlight this. The only methods we have right now to evaluate integrals are using area. Isn't what you did yesterday, where we did, like, you can do semicircles, or sometimes I gave you an area of an interval and you could use some math to find what it is. Or we could do an approximation using a Riemann sum, rectangles or trapezoids. So the only thing you're going to be asked to do today is to find that interval, but then you have to divide it, or find the integral, then you have to divide it by the interval. How do you get the interval? You just subtract those endpoints. That's where that b minus a comes from. Okay. All right, to get a more geometric idea of what the average value is, here's what I like to think of it as. If you had something that was like this, and it was frozen. It froze in this position, and then I thawed it, what would happen to it? It would come into, and then it would become water, so it would be whatever the container was. That's how you think of average value. We think of it as freeze and thaw, okay? So kind of like this, basically, if I would freeze this, and then I would thaw it, what I could do is I could figure out a rectangle in which the volumes or the areas were the same. That value is just the average value of the function. Okay, so let's graph x squared. You guys tell me what that looks like. Goes through 0, 0. What else? 1, 1. 2, 1, 2, 3, 4. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Huh, that's cool. Now, let's use our calculator to find this value. This is the integral from 0 to 3x squared dx. You do have to write down the dx, even though it doesn't change how you find the problem. It's, remember that formula. It's our formula for length times width. All right. Would you use FNH, please, to do that? Or, ooh, I like the calculator thing. The graph thing. I mean. 7, 0, 3, bam, 9. Graph this as a value as the function on the grid to the right. Does the function ever actually equal this value? Yep. If so, what point in the interval does it equal that value? X equals 3, right? What do you suppose is the relationship between the area between the x-axis and the curve y equals x squared on 0 to 3? Okay, let's put a different color. Let's take this area. What was the area under the curve? 9. You guys tell me if I made a rectangle, what color should I use?
Pink.
I want my rectangle to be 0, 3 still. How high would I have to make my rectangle to make it have the same area? Oh. So that pink rectangle and that integral 0 to 3 of x squared, okay, what do you notice?
3 squared.
Isn't it 3 high? The fact that it's 3 high, okay, that's the average value. That's the same thing. The fact that it's 3 high. It's the height of the rectangle. Okay. So this is called the mean value theorem for definite integrals. If the mean value theorem for integrals basically says if you're finding the area under a curve between x equals a and b, then there's some number between a and b whose function value, so somewhere in here it hits a 3. On this one it happened to be at the end point, but basically somewhere in there it does hit that value of 3. Let's see, what are they asking us to do here? What is an expression that could be used to determine the area under the curve from A to B? The expression is A to B f of x dx. What is the area of the shaded rectangle? B minus A times f of C. So that's when I'm talking about how that's just that height right there. Is that geometrically making sense, what I just did? I hope? Okay. Oh. Hey. You guys gotta remind me. Let's just look at this, but we gotta talk about this a little more. Remember back when I said average rate of change is not a calculus thing? Be careful of that distinction between average rate of change and average value. Average value is a calculus thing. Average rate of change is just f of b minus f of a over b minus a, correct? The only exception to that, this is where sometimes your mind gets blown, okay, you ready? The only exception to that is if the function that I'm giving you is a rate of change function. If the function I'm giving you is a rate of change function and I ask you to find the average rate of change, that becomes the same thing. So that's the only time when average rate of change is a calculus thing. So just be careful of that. Okay, so this was just the formal way of writing what we just discovered. And I talked on this. Those are different things. The only time they're the same is when the average value of the function, when this function that I'm talking about happens to be a rate of change. Cool. So, what are you going to use to find average value today on your worksheet? You are